Right now, above your head, ancient light is arriving. It left its source before a single human being existed, before language, before fire, before the first city was ever built. It has been traveling for 2.5 million years, crossing a void so absolute that nothing inside it even has a name, and nothing has ever passed through it and returned. That light comes from Andromeda, our nearest galactic neighbor, the closest major galaxy in the entire observable universe, and still functionally unreachable. And here is the part that should genuinely unsettle you. Even if you built the fastest machine physics will ever allow, powered by every resource on Earth, drained every reactor, every star we could reach, you would still never arrive. Not because we lack ambition, not because we lack imagination, not even because we lack technology or time, but because the universe itself appears to have quietly sealed every exit, long before we ever learned to look for one. So the real question isn't whether humanity can reach another galaxy. The real question is why the universe seems almost engineered to stop us from ever trying, no matter how far we advance. Let's find out exactly what's keeping us here, and what it actually means that we're trapped. For all of human history, distance has meant something temporary, something we could eventually cross, given enough time, will, and stubbornness. Oceans, deserts, mountains that swallowed entire expeditions. Even the freezing vacuum between planets, we found a way through, one impossible frontier at a time. That belief is quietly built into how we imagine our own future as a species. Starships, colonies, a civilization that spreads outward, generation after generation, forever expanding into the dark. Andromeda breaks that story completely. It sits 2.5 million light-years away, a number so large it stops behaving like a number at all and becomes something closer to a wall. If humanity is ever going to understand its true place in the cosmos, it starts with this one unbridgeable distance. A distance we cannot cross, no matter how many centuries, how much genius, or how much desperation we bring to it. This isn't a story about rockets failing or engineers running out of clever ideas. It's the discovery of a hard edge, the boundary of what any civilization, anywhere in the universe, will ever be able to do. Picture the entire walk from New York to Los Angeles, every mile of it compressed into a single step. Our nearest star, Proxima Centauri, would sit exactly one step away from where you're standing right now, close enough to almost touch. Andromeda would be roughly 600,000 steps beyond that, a walk with no visible end and no horizon to aim for. Light itself, the fastest thing that exists anywhere in the universe, takes just over 4 years to cross that first single step. To cross the remaining distance, that same beam of light needs 2.5 million years of uninterrupted travel. When the Andromeda light reaching your sky tonight first began its journey, our ancestors hadn't yet discovered fire. They had no language, they had no tools, they barely resembled the humans alive on Earth today. And astronomers still call that galaxy our neighbor, our close, familiar, next-door neighbor. It is, quite literally, the nearest major galaxy in the entire observable universe. Everything beyond it only grows farther, and stranger, and colder, until distance itself loses all meaning. So could we simply build something faster, something powerful enough to brute force our way across the distance, no matter the cost? This is where the story turns genuinely dark, and where hope quietly starts running out of road. Every spacecraft needs fuel, and fuel inconveniently has mass of its own. To accelerate that mass, you need more fuel, which adds more mass, which then demands even more fuel to move it. It is a spiral with no exit ramp. And physicists have a cold, clinical name for it: the rocket equation. Reaching just 10% of light speed would require more energy than entire nations consume in a full year. Now raise that target to the speeds true intergalactic travel would actually demand. The energy required exceeds the total lifetime output of every star it would pass on the way. This is not an engineering gap that future generations might eventually close with cleverness. This is the basic economy of physics itself, and physics does not negotiate with ambition. Some scientists point to generation ships, sealed vessels where children are born, live out entire lives, and die mid-voyage, never once seeing their destination. For a journey to our nearest star, that idea is agonizing, but at least theoretically possible within a few thousand years of travel. For a journey to Andromeda, the entire concept quietly collapses under its own weight. 2.5 million years isn't generations. It's geological time, the kind that reshapes coastlines and mountains. No empire in recorded human history has survived more than a few thousand years fully intact. We would be asking a single sealed ship to outlast civilization itself, 1,000 times over, without a single catastrophic failure. Other physicists point toward relativity instead, time dilation, near light speeds, shortcuts hidden quietly inside the equations. On paper, a traveler moving fast enough could experience mere decades where outside observers count entire millennia passing. But no shielding yet imagined survives radiation exposure across timespans that long, and no hull survives dust impacts at those velocities. The mathematics holds together perfectly on the page. The human body, unfortunately, does not. And even this isn't the deepest wall we're facing. There's something even more permanent waiting beneath it. The universe itself is expanding. And unsettlingly, that expansion is accelerating with every passing year, not slowing down. Space is quietly stretching between every galaxy that isn't gravitationally bound to our own local group. Beyond a certain distance, galaxies recede from us faster than light could ever cross the widening gap between us. Not because anything is moving through space faster than light, that remains, and always will remain, impossible. But because space itself is manufacturing new distance faster than light can travel across what already exists. Astronomers call this boundary the cosmic horizon, a line we can never reach, never see past, and never contact. Roughly 100 billion years from now, distant observers will look up into their night sky and see only their own galaxy, surrounded on every side by absolute, silent, empty darkness. They won't even know that other galaxies ever existed in the first place. So maybe the real question was never whether we could leave the Milky Way at all. Maybe it's simply what we choose to do with the certainty that we never will. The Milky Way alone holds 400 billion stars, scattered across 100,000 light-years of quiet dark. Countless worlds we haven't even glimpsed yet, let alone understood, let alone touched. An entire universe of mystery, sealed quietly within the walls of a single galaxy. We may never walk beneath Andromeda's sky or stand on a world orbiting one of its distant, unseen stars, but we can see it, we can study it, we can understand it light-year by patient light-year. Perhaps the walls of physics aren't a prison at all. Perhaps they are simply the shape of home, and somewhere above you right now, silently, that ancient light is still arriving.